on August 26th. Let's do it. Length of longest V-shaped diagonal segment. Given a 2D integer matrix grid of size n by n, where each element is 0, 1, or 2, a V-shaped diagonal segment is defined as the segment starts with 1, the subsequent elements follow this infinite sequence. So starts at 1, we have to go 2, 0, 2, 0. The segment starts along a diagonal direction, top left to bottom right to top left, top right to bottom left to bottom right. Continues the sequence in the same diagonal direction. Make a most one clockwise 90-degree turn to another diagonal direction while maintaining a sequence between the length of the longest V-shaped diagonal segment. So it starts at 1 and then follow the sequence 2, 0, 2, 0. So it starts along a diagonal direction, continue the sequence in the same direction, but you are allowed to make one clockwise 90-degree turn. So basically, if you go top left, bottom right, you can switch to top right, bottom left. So you can do this, turn this and turn, this and turn, and this and turn, and then you will form a V-shaped. Okay, so from here. Oh, this is also, because at the most one turn, so this is also allowed. So I have to start with 1. So okay, so I have 1, and then the next one has to be 2, which actually, yeah, I have some choices. Okay. And then you have to go 0. Go this 0, I can go this 0. I have many different zeros to go. And then at the end, you want to find the longest V. So as for each one, right, if we start from 1, we have a bunch of choices, and you make one of the choice, right, and you can go down. Like each one you have multiple choices, so each one you can do some choice, and then we have to like DP this, right? So basically at each one, at each cell, the question is, starting from this cell, what can we do? Starting from this cell, I have 4 directions that I can do. Okay, I have 4 directions, and it has to give me the previous, right? The previous direction. So the previous direction we can do DI/DJ, right? So basically, if we go DP, we have IJ, right? We have di dj. This is the previous direction, and turn, has turn. Okay, has turn. So that's all we have. And in each position, I have, these are the state, right? These are the state. And what we want to do at each of them, I want to know, starting from here, given the previous direction, this previous direction can be, you know, whatever it is, and you don't want to go like back, because that's just stupid, right? You don't want to go back. So you actually only have, because you have one, and then you only have like 3 directions to go, if you can go, right? So based on this, you have 3 directions to go. So you try 3 directions, and then find what's the maximum. This is kind of ridiculous. You have a 1, 2, 3, 4, 5. We have 5. Yeah, there are 5. Maybe we can Python this to use the RU cache. But I'm pretty sure this one will time out. Actually, I'm not sure if it's gonna time out. I haven't coded Python for such a long time. Well, if I time out, then just time out. There's nothing we can do. A length. Alright, so I'll probably have to have a sub. So we probably also need to have grid. Lord. Okay, so now I have a grid. We have IJ. Alright, so based on the previous directions, what's the end game? if you cannot go. Alright, if you cannot go. So we always try to go rest for the 1 because I add myself, right? So we say option 1, try to continue the path. Can't just say oh my goodness, this is wrong. Alright, so this is a 0, right? And then rest try to continue. And we say rest equal to maximum rest plus it should always be more. So plus equal to dp I plus di j plus dj di dj and half time. That's option 1. Option 2, oh shit. We need to know. Oh my goodness. I need to know if we can even do it. I need to do another function. That can continue. If self-grid ij is equal to 0 and I guess I don't need this. I think I just needed this. Or m or nj is smaller than 0, or nj is larger or equal to self.n, turn false. Otherwise, if this and self.grid ninj is equal to 2, a big or or self.grid ij is equal to 2 and self.grid ninj is equal to 0 or return true. Why don't you just return this? Alright, so return this or this. Okay, that can continue. Okay, perfect. So we say if self.can continue ij I plus di j plus dj. Right, if we can continue, then rest of plus equal to this. Otherwise it means we cannot continue, then we don't do it. Right, we cannot continue. Option 2 is try to turn 90 degrees if we have not turned yet. Right, so based on the dij, if we do a 90-degree turn, right, 90-degree turn, what does a 90-degree turn mean in terms of dij? So if we go, let's say, actually I'm gonna draw this. So if we do say this dij, I'm gonna say dij. Okay, so we can say this is a jj, right? It's after the turn. So if we go this direction, right, di is -1. We go up, dj is -1. So when we turn, we actually turn this way. Right, we actually turn this way, clockwise. So this will be I doesn't change, jj is +1. Right. Okay, so if I go this is the -1 +1, and we'll go this way, which is it's still +1, but this also be +1. Right. So now we go this is +1 +1, and then we go here, which is +1 -1. Right. And the last one is this, which is +1 -1. We'll go this way, which is -1 -1. Okay. Is there any pattern that you can find? Honestly, I don't think I can see any pattern. Honestly, I don't see any pattern. Like we keep this the same and then we change this. Then we keep this the same and we change this. I think it just has to be a mapping. Right? It just has to be a mapping. Like di is -1. Oh wait, hold a second. If di is -1, we go this, or we go this, then after turn there's always be +1 here. And this I will be following this. If di is +1, jj will always be -1, and I will be following this, which means I can have a helper function turn dij. Turn int. Okay, so if we say di go to -1, right, we shall return di is -1, jj is always 1, I the same as dj, so we say dj and 1. Otherwise return di is -1, no, di is +1, then jj is -1, jj is -1, so it's still dj and then -1. So that's the turn. Okay. Okay, I think I should be a tuple. Right, so that's turn. And this is option 2. We try turn. It has to be if not has turned. If I have not turned yet. Okay, if I've turned, then there's no way we have to follow through. If we have not turned, then we can call it IIJJ. I think that's a very poor use. So TDI, turn TDJ, okay? Turn DIDJ. Alright, so we got that. And then we say if self.can turn can continue IJ I plus TDI I plus J plus TDJ. If we continue, then res because we can only go one way, so shall we go to maximum res? Ooh-wee. Alright, that's actually not right. We should do this. It's either continue or you make a turn. So you only make one turn. Right, so res and self.dp I plus TDI J plus TDJ TDI TDJ that'll be false. Oh wait, hold on, this will be true because you have turned it. Turn has not been defined. Self dot okay, so rest will be this. So once we're done, I'll return rest plus 1 because I need to add myself as well. Okay, so that's that. So now what we're gonna do is for int for I range self.m for j range self.n if grid ij is equal to 1, and we have 4 directions, right? We have 4 directions. Oh, it has to start with 2, right? Then for DIDJ in, so 4 directions, doesn't matter, -1, -1. DIRs 1 -1 -1 -1. Okay, so we say DIRs. Okay, if actually it's not. If di is can do this 0 smaller equal to this and 0 smaller equal to j plus dj smaller self.n and grid I plus di j plus dj is equal to 2. Res equal to maximum res dp ij di dj false. Right, so we'll go through this blah blah blah, 4 directions, try them all, and and then return res. Okay. Not sure at all. I just copy something on the other one. That was very poor. Almost completely wrong on every single one. Quite interesting. That would be so wrong. Well, because at the end you return let's consider this one, right? So I continue. I can't. There's no turn. Or even if we have turn, I can't. So this one will return 1. So this position will return 1. So coming here, right? Return 1, and now I'm basically say I continue will give me 1. If I turn, I can't. Right, so this will give me this I should return 2. This should return 3, 4, 5. I don't understand. Alright, that's fine. Let's see if we can debug this. So answer should be 5. Okay, let's stay with DP. Okay, so here IJ 0, 2, 0, 0, 2. Okay, so the first direction is 1, 1. So go diagonal down. This is the right direction. This is the right one, right? The right one. So we go. I feel like they have 2, so can continue. That immediately go wrong. Can continue. Okay. 3 scenarios. And here, okay, we'll try this. Most of them, except for the last one. Ooh. All right, let's see. What is timeout? Yep, I think we're timeout. That's fine. All right, timeout. Well, oh, memory. No, it's good. It's good because we have showed that at least we have a brute force. Okay, we have a brute force to handle this. It times out. That's all right. We'll record it, and then we will do it some other time. This is it's actually not timeout, it's a memory. 3, 4, 5, 9. This is the brute force DP solution. As expected, it times out. No, it exceeds some limit. Right. In this case, the limit is memory. The error is memory. Error is memory limit exceeded. All right. So maybe it's because we are going through everything. I don't know. All right, for one, we can so ij, there's no way around ij, but di, dj, we can combine them into one element. It can just be a string, okay? That saves the memory. Has turn, yeah, we still need a has turn. That one has to be okay. So what if we update, put di dj into group di dj, right? Group di dj into a single variable. So we are here. We'll say, yeah, that's your di dj. Directions. dir. Say di dj. Oh Lord. Self dot. Okay, so we say self dot dir. Okay. Not sure if that, actually no, dir will have to change this. This is the same dir. Ah, shoot. Screw me. Actually, no. dir int. I don't need to give a turn. I can just self.turns. So if it's 0, 1, 1, 1, 1, turn to 1 minus 1. 1, 1, turn to 1 minus 1. 1 minus 1. 1 minus 1, turn to minus 1. 1 minus 1, minus 1, minus 1, 0, 1, 2, 3. Minus 1, minus 1, minus 1, 1, turn to 1, 1. Minus 1, 1, turn to 1, 1, which is 0. Minus 1, minus 1, turn to minus 1, 1, minus 1, 1, so 0, 1, 2. Okay, that's turn. Which means I still need this. I need this. This is wrong. So what we need is self.turns dir to give you that, and then self.dir's turns. Okay. So this is not needed anymore. So we got this. This I also don't need. I can just call it dir, right? Ninj equal to I plus self.dir. Oh. didj self.dir is dir. Ninj I plus dij plus dj. Okay, so can continue or change this to dir. That's fine. And here tdir. Okay, tdir. So this will go with tdir. And this will be tdir. Actually, no, that's not right. We'll get the tdir, and then the tdi, tdj, dir's tdir. So we still do the same tdir, and then this. Ah, screw me. Ooh, hold on a second. I don't need to do this. I can do this. All right. Oh, I don't need the idj. Now we just say for the R in range 4. Not sure if it's gonna fix any of the issues. Okay, so these are good. How about this? I think that's too bad. Oh, it's actually not. Alright. Let's see. That's basically how lenient it's gonna be. And nope. Still. Nope. Nope. Still MLE. Alright. Let's give up. Check the tutorial. I mean, we're in Python, so might as well just go Python. I'll copy and paste. Alright, so this is this is a copy and paste. Wow. It still does quite a lot of steps. I don't understand. How does it make it so much faster? I don't know. I don't know. Think it's worth investigating. Alright, we'll investigate it some other time. I feel like very close. I mean, the setup looks very similar, right? Even this looks similar, right? Direction and range for we do this as well. We even check if it can continue. And mass, yeah, that the setup is very similar. IJ direction and true. IJ direction and true. I think the only difference is I also have the cache. I honestly don't know what is the difference. So it has turn, right? What is this target thing? Oh, so if it's a 0, it becomes 2. If it's a 2, it becomes 0. If turn clockwise, rotate. Huh. That's exactly the same. What in the world? That's exactly the same as my solution. I just make some more function calls. Don't tell me it's because of these that drive it above. It says it's memory. It says it's memory. I don't know why. This has 1, 2, 3, 4, 5. I only have 1, 2, 3, 4. Honestly, I don't know. I don't know why. It's literally the same. It's the same solution, but mine has memory exceed. I don't know. Memory, can I do this? Yes. what if I don't do this? For whatever reason, it's just so slow. And it's so taking so much time. Yeah, well, we have to. What if we just do cache? Does that work? Oh, I don't know. Cache. I mean, seriously, like, what's the difference? Okay, function calls. Function calls. Hold on, let's do this again. So you're telling me that the difference is because, dude, I am going to be so mad. It's likely it's because of these if and else. It's likely. Okay, so what are you saying? That we don't do this? Okay. And then we just say or I large equal to self.m or j small 0 or j large equal to self.n return 0. Right? Then we don't do this, we say this. But they have to do this, yeah. Target. Okay, we'll do target. If it's not equal to target. Right? If it's not equal to target, then we'll return 0. Otherwise, target minus 2. Two minus target. So target can be 0. 2 minus 0 is 2. Right, so 2 minus target. Alright, that's the next one. Ah, I don't even need to do this. I can just say from this, I do the turn. What will be the maximum? That's actually not right. You can't make the current direction to the next one. It's okay. I think I'll stick to what I'm doing. So the current, if it's bad, let's return 0. Otherwise, I do this, or I make a turn. I do this. Okay. So here, target. So target should be 2. Yeah, it doesn't hurt to try. Some inner workings of Python. That's my guess. I don't know why. This is I mean, we changed the algorithm a little bit and then it kind of just blows at us. All right, let's see. Maybe we can I don't know, debug this. Thread stopped due to exception. Huh? Oh, my bad. I need to copy and paste this whole thing. I think I made some changes earlier. Okay. And then we'll go here. Okay. So what do we have? ij02, that is correct. Direction is 0, that is correct. Has turn is false. Target is 2. So in here, go this should be true. Huh? What? Oh, shoot. No. I should go for the next one. Damn it. That's alright. DIDJ. I have to do DIDJ. Wow, it's... Oh, I don't even need to do this. Hold a second. DIDJ, right? I can enumerate this. I can say enumerate self.dirs. And then this has to be plus di. This has to be plus dj. And I have to plus 1. Alright, let's try this version. It's faster. Interesting. What if I use cache? Instead of LRU cache, I just use cache. Nope. What if I put this one inside? Update 3. What if I put the DP function inside? That'd be funny if that's the reason. Well, for one, all the self can be removed. Well, I'm still gonna go LU cache. And then all the self. So one more self, this one can be removed as well. Alright, that's all the change we made. It just gets faster and faster every time, huh? Okay, here's my theory. My theory is this LRU cache, this has to be defined inside, and then the memory is shared every time we call this DP. Okay, every time we call this, it reuses the previous cache. If I define it outside, then every time I call, it recreates the new cache while not removing the previous one. That's why we have the memory issue. I think that's the reason. Yeah. So it turns out that the MLE is due to the DP function being defined outside line of a diagonal when it is defined within len of the diagonal, it reuses the same cache, right? When it is defined outside, it creates a new cache each time DP is called, which is why we have MLE. Now this is my speculation, which makes sense, but I am not sure if it is accurate. 38138 80%. So yeah, it's actually not difficult, but it's just the Python issue. Okay, I'm curious. How did you do on this? Holy my moly. Okay. I think it's the right call to use Python for this, but yeah, it's really not that difficult. Honestly, it's not that difficult. You just need to make sure that you are okay with this little. That's not a trick. It's just like knowledge. You have to define it inside. All right, that'll be it. Now I'll see you